Have you ever wondered what it takes to send a robot to Mars? This isn't just a hypothetical question. It's a marvel of modern engineering that was brought to life with the Mars rover Curiosity. This intrepid explorer, designed to unravel the mysteries of the Red Planet, successfully touched down on Martian soil back in 2012. Its mission? To investigate the Martian climate and geology and to pave the way for human exploration. But behind this ambitious project was a team of dedicated engineers, including one very special individual. Meet Alex Nicholson, an engineer hailing from the picturesque island of Skye. His work on the Curiosity rover project has been instrumental in pushing the boundaries of our knowledge about space. Now you might be wondering how much effort really goes into getting a robot successfully into space. When we think of space exploration, we often think of astronauts. But what about the engineers on the ground? Let's take a moment to appreciate the folks who don't get to don the suit, but are equally instrumental in our celestial pursuits. Today, we're focusing on one such individual, Alex Nicholson, an engineer from Skye who worked on the Mars rover Curiosity project. Alex is one of those unsung heroes who play a pivotal role in space exploration. As an engineer, his contribution goes beyond just building and testing. It's about problem-solving, innovating, and creating machinery that can withstand the harsh realities of space. From the conception of a mission to its successful execution, engineers like Alex are involved in every step along the way. They design and build spacecrafts, create systems to sustain life in space, and develop instruments to gather data. It's their ingenuity that transforms a concept into a reality, a dream into a mission. In the context of the Mars rover Curiosity project, Alex was responsible for ensuring that all the systems and subsystems of the rover functioned correctly. This involved rigorous testing and retesting, making adjustments, and solving any issues that cropped up. He was a part of the team that ensured that Curiosity was equipped to handle the harsh Martian environment and could carry out its mission of exploring the Red Planet. But the work of an engineer doesn't stop at the launch. Once the spacecraft is in space, they monitor its operations, troubleshoot problems, and even devise solutions from millions of miles away. When Curiosity landed on Mars, Alex and his team didn't just sit back and relax. They continued to work, analyzing data, solving problems, and ensuring that Curiosity was able to complete its mission. So the role of an engineer in space exploration is multifaceted and critical. They are the ones who turn the impossible into the possible, who take us to the stars and beyond. So, as you can see, without engineers like Alex, our exploration of the cosmos would be impossible. Now let's delve into the technicalities of the Mars rover Curiosity. Imagine a car-sized, six-wheeled robot weighing in at about 1 ton, equipped with the most sophisticated scientific gadgets. This is the Mars rover Curiosity, a marvel of engineering and space exploration. Curiosity measures about 10 feet long, not including the arm, 9 feet wide and 7 feet tall. It's roughly the size of a Mini Cooper car, but it's packed with far more advanced technology. The rover was designed to roll over obstacles up to 25 inches high and travel about 30 feet per hour on flat, hard ground. The rover's arm is about 7 feet long. At the end of this arm, the turret holds 5 devices that can spin through a 350-degree turning range. It's like a Swiss Army knife of scientific instruments, equipped with a drill to collect rock samples, a scoop to gather soil samples, and several cameras for detailed imaging. Powering this beast is a radioisotope thermoelectric generator, or RTG. This device converts the heat from the natural radioactive decay of plutonium-238 into electricity. This powers the rover's instruments, robotic arm, wheels, computers, and radio. It also keeps the rover's systems warm enough to function in Mars' harsh environment. One of the most critical systems on Curiosity is the Autonomous Navigation System, or AutoNav. This allows Curiosity to find its way around Mars without constant direction from controllers on Earth. It's a bit like a self-driving car, but the environment is much more challenging and the stakes are much higher. Curiosity's primary mission is to investigate whether conditions on Mars have ever been favorable for microbial life. To achieve this, it's equipped with an array of scientific instruments. For instance, the Sample Analysis at Mars, or SAM, is a suite of instruments that can identify organic compounds and determine the isotopic ratios of key elements. This helps scientists understand the planet's geological history and potential for life. Constructing and deploying the Mars rover Curiosity was a challenge of epic proportions. It took the collective efforts of hundreds of dedicated engineers and scientists over several years. And the challenges did not stop at launch. The landing, famously dubbed the 7 minutes of terror, required the rover to withstand temperatures comparable to the surface of the Sun, slow down from over 13,000 miles per hour to zero, and land safely on the Martian surface. Despite these challenges, the Mars rover Curiosity has been a resounding success. It has provided invaluable data about Mars, paving the way for future missions and bringing us one step closer to answering the age-old question, are we alone in the universe? It's fascinating, isn't it? The complexity of this machine that's now millions of miles away exploring another planet. Getting to Mars isn't as simple as hopping on a spaceship and hitting the gas. No, it's a cosmic ballet of science, engineering, and a little bit of luck. Let's take a moment to appreciate the journey that the Mars rover Curiosity had to undertake to reach the red planet. The journey from Earth to Mars is no small feat. It's a staggering 140 million miles, give or take a few million due to the planet's orbits. That's like circling Earth over 5,500 times. To travel this distance, Curiosity was packed into the Mars Science Laboratory spacecraft and launched into space on an Atlas V rocket, one of the biggest rockets available. Once in space, the spacecraft had to navigate the vastness of the interplanetary space, a journey that took about 8.5 months. This is where our good friend gravity assists, curving the spacecraft's path and boosting its speed to set it on a precise trajectory towards Mars. But reaching Mars was only half the battle. The real challenge was landing. You see, Mars has a very thin atmosphere, only about 1% as thick as Earth's. This makes slowing down a spacecraft traveling at over 13,000 miles per hour quite tricky. To overcome this, engineers designed a unique and complex landing system known as the Skye crane. After entering the Martian atmosphere, a parachute and retro-rockets slowed the descent. Then the Skye crane took over, lowering Curiosity on tethers to a gentle touchdown. This had to be done with extreme precision, as any error could result in a catastrophic failure. And then, after a journey of millions of miles and months of anticipation, the moment of truth. The signals confirming a successful landing came back to Earth, and the team could finally breathe a sigh of relief. Just imagine, after all of that, finally seeing the red surface of Mars through the eyes of a robot you helped build. Now, what has the Mars rover Curiosity accomplished since its arrival on Mars? It's a question that's worth pondering, isn't it? Since its landing in 2012, Curiosity has been a busy explorer, making groundbreaking discoveries and contributing significantly to our understanding of the red planet. Its findings have painted a more vivid picture of Mars, allowing us to delve deeper into the mysteries of our solar system. One of Curiosity's most significant discoveries came in its first year on Mars. It discovered sedimentary rocks that suggested Mars once had flowing rivers and lakes. This discovery fundamentally changed our understanding of Mars, providing the first substantial evidence that it was once a planet capable of supporting life. Curiosity also detected a tenfold spike in methane, an organic chemical in the atmosphere around it. The implications of this finding are profound. As on Earth, methane is produced by living organisms. While it doesn't confirm life on Mars, it certainly opens up intriguing possibilities. The rover has also been crucial in studying Mars's climate and geology. Its findings have shown that Mars has a diverse and complex geological history with evidence of ancient volcanoes, crater impacts, and even potentially habitable environments. But these scientific discoveries are only part of the story. Curiosity has also had a significant impact on human interest and engagement in space exploration. Its journey and the stunning images it sends back from Mars have captivated millions of people around the world, inspiring a new generation of scientists, engineers, and space enthusiasts. These achievements are a testament to the dedication and ingenuity of engineers like Alex Nicholson, who have poured their heart and soul into making the Mars rover Curiosity mission a success. Their work has not only expanded our knowledge of the universe, but also demonstrated what's possible when human curiosity and technological innovation combine. And to think, all of this was made possible by the hard work of engineers like Alex Nicholson. So, the next time you gaze up at the night sky, remember that there's a piece of human-made technology out there, exploring the unknown and pushing the boundaries of what we know and where we can go.